By the time we're done with the warm-up, we want you to have all the correct answers on your paper. So if you're someone who got them all right the first time, awesome. You're sitting there nodding, going, yes, that's exactly, yes, Mrs. Burris is not messing up. Sometimes I will mess up. In that case, just go, Mrs. Burris, I don't think that's right. Because that's how we learn, is by doing things wrong and then getting better at them. So if you had them all right, awesome. You're just verifying how wonderful you are at math. If you got them wrong, I want you to write those correct answers and the correct procedure. I don't want just a final answer. I want you to have that worked out on your paper. If you need to go ahead and have that on the back, if you already have some incorrect on the front, that's okay. But you want to have that so you can access that on the test report. So let's go ahead and take a look at that first problem. What we're looking at here is solving for x as always. So we always start with whatever that highest power is, and we get rid of that first. So our highest power is that x squared. So in order to get rid of it, we're going to do the opposite operation. So the opposite operation of 3x, or having a positive 3x, is subtracting 3x squared here from both sides. So we're going to subtract 3x squared from both sides, and conveniently enough for us, so we don't have to do the quadratic formula or generic rectangle diamond problem, they both completely cancel out because 3x squared minus 3x is 0. So what we have left is 3x is equal to 6. So we're going to finish solving for x by doing the opposite operation of multiplying by 3. The opposite of multiplying by 3 is dividing by 3. And we're going to make that look like a fraction. So we're going to divide both sides by 3. And as you know, 3 divided by 3 is 1. 1 times x is x. So that's how we have isolated our x. And on the other side, we have 6 divided by 3. So our x is equal to 2. Now to check our work, we would simply plug in 2 for x and solve if we're interested in doing so. So that's 4 times 3 is 12. 12 plus 6 is 18. On the other side, I have, once again, 12 plus 6, 18. 18 is equal to 18. So we're correct. Okay? Now, our second one, there's a whole bunch of different ways that you can solve. Some people do something called the butterfly method. Personally, I like to simply solve for x. Now, whenever you have your x in a denominator, we want to clear it out of the denominator. Denominators are basically really hard to solve things for. So we're going to do the opposite of dividing by x, which is multiplying by x. So we're actually going to multiply both sides of our equation by x. And just like up here, 3 divided by 3 was 1. X divided by x is also 1. So that allows this side to have those x's cancel out. And all we have on that side is 5 is equal to, here I have 1 times x is x, and that's divided by 3. So we've cleared that x. It's no longer in the denominator. Now we're looking at a problem that's much easier to solve. So here I have x divided by 3. My last step is to do the opposite operation of dividing by 3, which is multiplying by 3. So we're going to go ahead and multiply both sides by 3. Once again, 3 over 3 is 1. 1 times x is x. So x is equal to 5 times 3 is 15. Now, if I were to plug that in the original equation, I would have 5 over 15, which reduces to 1/3. So once again, we reduce both of those. 1/3 is equal to 1/3, and we can verify that we did that correctly. Let's go ahead and take a look at that third one. Now, whenever we have a number or a sign outside a set of parentheses, we need to use the distributive property to go ahead and multiply that to each and every term on the inside of that set of parentheses. So I have a negative times 2x, and I have a negative times negative 3. So that gives me 5. A negative times 2x is negative 2x. And a negative times negative 3 is positive 3. And that's equal to negative 3x plus 6. Now, before we can start moving letters from one side to the other by doing the opposite operation, we have to combine like terms on either side, which means if we have multiple x's on one side, we need to add or subtract those together. Here we have 2 constants on the same side, so we need to put those together, combine our like terms before we move on. So I have a 5 plus 3. 5 plus 3 is 8. So we have 8 minus 2x is equal to negative 3x plus 6. Now we have combined all of our like terms on either side. That means that what you have left is a plain number, a constant, and an x. So now it's time to start moving stuff from one side to the other by doing the opposite operation. I always take the smaller one and move it over to the other side. That way, it's going to be a positive number. So over here, my smaller one is negative 3x. So I'm going to do the opposite operation of negative 3x, which is positive 3x to both sides. Negative 3x plus 3x cancels out. And over here, I'm going to go ahead and move my work over here. I have 8. Negative 2x plus 3x is simply positive x, and that's equal to 6. Now we're left with a one-step equation. All we have to do is the opposite operation of 8 here, and that's the only thing that's stopping my x from being isolated. So the opposite of 8 is negative 8, and 8 minus 8 cancels out, and what I have left is x is equal to, and 6 minus 8 is negative 2. Okay. And once again, if I plug that in, I have 2 times negative 2 is negative 4. Negative 4 minus 3 is negative 7. 5 minus negative 7 is positive 12. If I plug it in over here, negative 3 times negative 2 is 6, and 6 plus 6 is 12. So 12 is equal to 12. So once again, we verify that we are correct. Okay, our last one here has a number outside the set parentheses on both the left and the right. So we're going to go ahead and distribute on both of those. Okay, so we have 6x, 6 times x. 6 times negative 3 is negative 18. And then we drop down our plus 2x. On the other side, we have 4 times 2x, which is 8x. And 4 times positive 1, which is positive 4, minus 22. Now it's time to go ahead and combine like terms. On the left-hand side, we're combining our x's. We have a 6x plus 2x, which is 8x minus 18 is equal to. On our right-hand side, we're combining the constants. We have a 4 minus 22. So that is 8x minus 18. Now that we have combined our like terms on either side, it's time to move our letters from one side to the other. So I have an 8x. I'm going to subtract 8x from both sides. And shockingly enough, they both go away. Now, what I have left is negative 18 is equal to negative 18. Now, once our variables go away, we ask ourselves a question. We ask ourselves, is this true? If your answer is true, it makes a true statement, then your answer for the problem is all real numbers. However, because negative 18 in this case is equal to negative 18. However, if it was a false statement, for example, if you had negative 18 is equal to 5, no, it's not. It's a lie. So many lies. Then your answer is no solution. All right? So once your letters fall away, if it's true, your answer is all real numbers. Now, what all real numbers actually means in math means I can plug any number in the universe in for x, and it's going to make this statement true. I can plug in a 1. I can plug in a 5. I can plug in a negative 22, and it's going to make it true. However, sadly enough, if I have a no solution, it means in the entire universe of all numbers that exist in the world and imaginary numbers that don't even exist, there's nothing I can plug in to make that statement true. It's a failed equation. It's very sad. So our answer for that last problem is all real numbers.